All right, so I'm going to talk about cloud native WebAssembly, and promise I will try and tie that into NATS at some point. So before I get going, I just want to take time to shamelessly self-promote my book. Earlier, there were some talks about Rust, and as you'll see, some of the samples that I'm going to go through, the samples that I've got are in Rust, although some of the demos also have assembly script samples. We mentioned a tiny bit about WebAssembly earlier, but the basics are that WebAssembly is not JavaScript. It's a stack-based virtual machine. It's operating system and processor agnostic, and I think those two characteristics are some of the most important ones when it comes to running it in the cloud. And like I said, it's not just for browsers. WebAssembly works anywhere that the host and guest can agree on a contract for how to communicate. And in one of the earlier sessions, I forget which one, there was mention of NATS wanting to have the ability to execute WebAssembly for custom logic. And as long as NATS and the guest modules agree on a contract, they can do that. So the project that I'm working on is called the WebAssembly Secure Capabilities Connector. And it's essentially a way of running WebAssembly in the cloud by dynamically connecting your WebAssembly module, or what we call actors, to cloud native capabilities, one of which is NATS, but other ones are things like key value stores, SQL databases, HTTP servers, all of the things that your applications tend to need when they're running in the cloud. Security, those of you familiar with the NATS 2.0 security model will find an awful lot of what I'm doing with signed JWTs to be suspiciously familiar. It's basically because I ripped the idea from Derek. The actors are flexible, and they're the point that I think aids in some of this productivity that we want to give developers in the cloud is that the capabilities are dynamic at runtime. So you can swap actors in and out at runtime. You can swap capabilities at runtime. So I can take NATS and replace it with some other message broker. Not that I ever would, but you could swap Redis for Cassandra, things like that, all at runtime without ever having to redeploy or even recompile your actor module. And again, I'm going to try and keep things moving as fast as possible. So if you want to take a look at the documentation, it's waSCC.dev. There's a number of different aspects of the WebAssembly connector project that I'm working on that I normally talk about, but I think I want to focus on removing boilerplate from the developer experience. And so when we're building our cloud native applications today, we have to worry about an awful lot of stuff, more than just the business logic that we're writing. We have to worry about HTTP servers and standing up web-based endpoints. And if we're deploying in Kubernetes, we have to worry about that even if our application doesn't even serve HTTP, because we need to be able to deal with exposing health and readiness endpoints. We need to connect to databases. We probably have to deal with caching at some point, message brokers, security or resiliency, monitoring, tracing, essentially a bunch of the things that we've already seen sessions on today. We need to be able to scale our applications up and down. We need to be able to turn them off if we can to save money and resources. And we also have to figure out how to actually bundle these applications and deploy them. And there's a tiny little bit in there, usually about 10% of the time we spend, that's covered on where we actually get to spend our time writing business logic. And what we should be spending our time doing is worrying about the business logic. We should spend 90% of our time writing features and then only 10% of our time dealing with the rest of the stuff. And it's our hypothesis that we can use some of the limitations and the benefits of WebAssembly, especially the sandboxing aspect of it, to give us the ability to worry about just our business logic. And so today, developers have tons and tons of tools. In fact, I think we probably have too many tools right now, especially if we're dealing with Kubernetes. We're essentially given, you know, as the picture shows, we're given these buckets of plastic beads and told to melt them into whatever shape our application needs to be. And it works well, but, you know, and we end up with these bespoke applications that do what we want them to do. But I personally don't think that's the right abstraction level to be building our applications in. What we really want are Lego bricks that we can reuse and plug together for one purpose and then pull them apart and put them together again for a different purpose. But today we're all essentially, you know, melting our own bricks before we actually get started building our Lego houses. So what I want to do is show a demo of WebAssembly in the cloud. And what I'm going to show is a microservice that listens to a NATS subject, and every time it receives a message, it adds to a counter that it's storing in a key value store. And it also exposes over HTTP a JSON endpoint that gives you the current value of that counter. And as I go through the demo, I just want everybody to try and keep in mind the amount of boilerplate and the amount of you know, client code that they would have to copy and paste and throw into their project in order to make this thing possible, even though the business logic is really, really small. The business logic should be a few lines of code, but you know, from having written this type of thing in Go and C and Java and a bunch of other languages, the business logic usually ends up getting hidden behind all of the stuff that we've had to copy and paste. And hopefully we can make that change. So let's see if I can get Visual Studio Code to show up here. So hopefully you can see this. Did this get cut off?
No, we can see it.
Okay, so this is the entire contents of my microservice. Let me just see what's going on in chat here. Okay. Yeah, so in my service, I'll highlight it so you can see here. I've basically just defined the list of messages that my WebAssembly actor responds to. And in this case, an HTTP request, a health request, and a message from the message broker. And what's not shown here is how the HTTP request is delivered, how the health request is delivered, or how the message broker delivers the message. All I'm declaring is my intent and not how that intent is implemented. The non-functional requirements are nowhere to be found in my code. And so this function here just returns some JSON that gets the current value of the counter. And the current value of the counter comes from my key value store. And this could be, again, this could be any key value store. My code is not tightly coupled to which one. I'm currently using Redis, but like I said, I could use an in-memory one. I could use Cassandra. I could use anything that conforms to this key value contract. The handle message function, this is the one that I've set up as my message broker message handler. This will respond to a NATS message, and it just adds one to the counter. And again, calling one key value function with no boilerplate. And finally, just the health request, the health handler. And if I return Rust's OK, that tells the host runtime that my WebAssembly module is functioning the way it should. So, oops, pretend you didn't see that. So the first thing that I would normally do is I would build a release version of my WebAssembly module. And again, as I mentioned earlier, I've completely stolen my security model from NATS. And so if you look at the WebAssembly module that I produce, yep, this is why nobody ever does live coding. So I'm examining the signed JSON token that's inside the WebAssembly module. It's embedded directly in it. So one thing that we can't get with Docker is we can't bundle the capabilities and permissions of that Docker module or that Docker bundle with the Docker file itself. Its capability attestations come from somewhere else. And with it being embedded in the WebAssembly module, this portable module has the same list of permissions regardless of where it goes. And so you can see that it's been granted the permission for a key value store, messaging, and an HTTP server. And again, if you've been paying attention to the NATS 2.0 security model, you'll see that these look very suspiciously like N keys. And again, that's because that technology is completely stolen. Oh, that's perfect timing for a phone call. So let me just show the code for the host runtime. The first thing that I've got is a host manifest, and the host manifest is just a YAML file that describes which WebAssembly modules I'm going to load into my runtime host. And these are actor bindings. And so I'm binding the actor that is identified by this public key to the messaging capability with the subscription and this URL. And note, this capability doesn't actually say NATS anywhere. The assumption is that that capability is going to be satisfied at runtime, and that anything that conforms to this capability contract is a suitable replacement. I'm also binding HTTP server on port 8080, and the key value store is using this connection string. And the host code to build a binary that loads those actors and those capabilities is, again, just a couple lines of code using the waSCC GitHub project. So what I can do is run the demo host. And you can see that it has loaded HTTP server provider, messaging, key value. You can see that actor binding has been taking place, and that it has a web server started on port 8080. So if I publish on the subject that thing is listening on a couple of times, you'll see that it received a host call, that this actor handled the message that I got from NATS. And now, if I hit the web server for that, I now get some JSON that actually has the current count. And again, this is a microservice that compiles down to a portable file that doesn't need to be rebuilt to run on different architectures, doesn't need to be rebuilt to move between a Raspberry Pi or a Docker image or Kubernetes. And one other fun fact on these WebAssembly modules. I always forget what order those go in. It's 2 megs. So this microservice that runs an HTTP server, listens to a NATS topic, and communicates with an atomic counter inside a Redis database, consumes less disk space and less RAM than an animated GIF. And see if I can get back to the slides. Okay. So why is this related to NATS? I think earlier when NATS was compared to plumbing, I think that's pretty accurate. I think it was at KubeCon, there was a phrase people started using where they wanted boring infrastructure. They wanted infrastructure that wasn't exciting and stuff that they could just forget about. I want infrastructure that is a light switch. If I switch it on, I want the lights to turn on and I don't want to have to worry about it anymore. And of all of the things that I have to deploy in order to get my applications working, NATS is always the thing that I don't worry about. I can spend some time building NATS-based architectures, but in terms of which piece of plumbing works, NATS always works. And so when I had to figure out which capabilities I was going to give to these WebAssembly actors first, NATS was the first one that I wrote, because you can use NATS as one of those Lego bricks to build other things. And so being able to have that as a first capability was important to me. And so like I said, it's that piece of infrastructure that I never worry about. And so that was all I had.
Thank you, Kevin. I'm always inspired by how Kevin kind of tries to push the envelope. And for those that know a little bit about me, know I spent a little bit over a decade of my career in deployment platforms, right? With mostly around platform as a service as kind of an interesting one. And not only am I excited about Rust, as we talked with Tyler early on, and WASM, which I think Kevin is highlighting. And again, he's way ahead of the curve. I think he's waiting for WASI and initiatives like that to kind of catch up to some of his thinking. But I will put a little observation out, and I'm normally wrong, so don't feel bad if you don't agree with it. But platform deployment technologies don't get replaced by newer, better platform deployment technologies. They get replaced when the unit of deployment changes. So for example, going from a VM to an application was from VMs to applications in the birth of PaaS. PaaS seeded back in terms of, hey, we want to have a little bit more control and we want to go more back to an IaaS. But the reason that all of a sudden it succeeded and things like Kubernetes, I think, came into being was because we moved to containers, right? Docker, but containers. And I think, and again, this is just my observation, that that trend continues to happen. OpenStack was VM, tried to make the jump to containers and really didn't, right? It was left behind. I think WASM and the ability to deploy these things at scale securely with very minimal resources is going to be that next major transition in deployment platform technologies, because we're going to change the unit of deployment. So definitely keep an eye out for the stuff that Kevin's working on and some of the ecosystems. It's still very, very early. Kevin's running ahead of a lot of folks, but I'm really excited about where it's trying to drive us. And again, for me, I just try to focus on simple and predictable, right? But if we change that unit of deployment, I think you're going to see some changes in the encompassing technologies, right, that do the deployments today. So, Kevin, thank you. I really, really appreciate the time. Great talk.